So today I'm gonna, while waiting for people, I'm gonna start making a very small design because I want to test out the, what do you call it, 4-layer boards, things like that. Also try to compact it as close as possible. Today I'll use KiCad instead of Altium, so I'll shuffle between the two. Let's share the screen. There we go. Seems good. There we go. So I'm going to make use of the ESP. I need a voltage converter, yes. So the circuit I drew for the drone, so I'm going to use the same circuitry, just use it for a different aspect. So let's see what we can do. This will probably be the smallest PCB I've made. How's everyone doing? So if I look at my PCB, let's go. Update. Someone is drilling. Oh, it's a bit slow. I need to close some stuff, I think. This PC is not handling everything. Come on. It happened last time as well. I think the PC is giving up on us. I think C drive. Where's KiCad running from? Come on. Did I save it? Oh, PC struggling. So I normally take old schematic I've done before. So the drone we've done, we know it works. Now delete the circuits I'm not going to use. Save. Let's hope for the best, eh? Just trying to get rid of all the processes running at the back because this, I don't know what is going on. Okay, that's a good start. Good start, good start. Let's try import now. Ah, not responding, man. Let's just give it some time. Otherwise, I have to go to Altium. I don't know what's going on. So I'm just trying to import this from schematic to the PCB. It's not good, man. Not good, not good. Ah, there we go. Just be patient. Save, save, save. Place line. So let's try and make a board outline. I'm actually going to make a circular one. Hey, Norris. Depends. So if I do quick prototypes, I normally go for JLPCB if I just want the PCB and I'll solve them myself. But if I want bigger volumes and I want them to populate the boards for me, I'll use PCBWay. So I use two manufacturers, JLPCB and PCBWay. I haven't used any other actually. And yourself, which ones do you like? So what I want to try to do is I'm going to make a PCB that I'm going to try to get on the back of that handle there. So I like to play squash, and we keep forgetting to count the score. So I'm going to try and make something, put a PCB there, and then when I hit it, it'll count the score for me. It's a nice challenge to make something that small with the ESP. So I just wanted to see the size, so let's say 3.15 centimeters. That is the circumference, the diameter, divided by half, so let's say 1.55. That's not right. Oh, this is possible. Yeah, so when I do something like this, I'll order from JLPCB. They're quite cheap and they're quite quick. But when I do more production, then I'll go to PCB Way. But JLPCB can also do population, but only on one layer. So you either choose top or bottom, and they will solder it for you. Every bit helps. So it's also a nice example of how a PCB can actually be a circle as well. It doesn't have to be a square. Think about programming it. I don't like this footprint. For me, no, it's not 2 weeks. So if it's the just bareboard PCB, they deliver to me in 5 to 6 days, about a week max. But I think it's a bit different in India at the moment. Hey, I see Cretius here. No, so JLPCB will populate or make your board in 48 hours, and then they'll ship it. So it depends on the shipment. Krish, let me know when you're ready to come on. Then I can help you. Are you from India, right, Naris? Or hey, welcome back. You guys make it very difficult to say names, man. Yes, how's it going? Oh, yeah, Mauritius. That is so cool. Wow, Mauritius is close to South Africa. Yeah, I think we're quite lucky to be, part of the main country. So a lot of stuff gets shipped here every day. Mauritius. I don't know if I was on at a power supply yet. I just want to get a different footprint. So you can get same components, but with different footprints. Yeah, there's a lot of South Africans. So in South Africa, if people go away, they go to Mauritius. I've never been before, but apparently it's beautiful. So how's the PCB world in Mauritius? This should go, right? There we go. That's what I want. I wonder if we're going to fit everything in here. That's a very good question, actually. I can bring it up. What's the difference between the various footprints for the same component? It's actually a very good question. It does not affect. So let's say, for instance, with MOSFETs, if you don't have a heat sink or something, you're having a lot of current through it, then the footprint can help. The bigger the surface, the more heat you can dissipate. In this scenario, I'm not actually sure why they have the other footprint. I just enjoy this one to solder. I've used this one all my times. But the other one, put both on. Let's think about it. That's actually a very good point. For this way, it won't make a big difference. I'm just wondering now in what scenario it would. U1. So let's make this. I always think about, okay, I have to solder this. What makes it easy for me to solder? So you can see this footprint and this footprint, they're both the same IC. They both do exactly the same thing. As you can see, they use the same pinouts. I'm not actually sure. It's a very good question. It's a bit bigger, so the heat dissipation might be bigger, but you don't use all the pads as well. I'll actually have a look because they have different numbers as well. Why would you want to use this one instead of this one? I know with MOSFETs it helps with power dissipation. And also, like, you can have different ICs that might have be a QFB, like with the leads, or you'll have one that's at the bottom. So that's also just, if it's at the bottom, you can put your components a bit closer where they spread out. You save a lot, but you don't save a lot, but on a PCB that's packed, you can save a lot. But for this scenario, I'm not too sure what would be the biggest difference, to be honest with you. I know with ICs, you get leads in, leads out, things like that. But I'll get back to you. I'm quite interested now why this will be twice. I think it has to do with power dissipation, but I'm not too sure. I'm guessing. It also can be that this is generic pads. So this footprint is a generic footprint that can have many ICs. So they probably just took over the footprint and then just used certain pads inside. Because this is a SOT5, or you'll see here. So it's a SOT23. That is just the footprint. So you get a lot of other ICs with the same footprint, but do different things. So I've got a battery charging IC that looks exactly like this. So I have to be very careful that I don't switch them around. So that might be another reason why you would choose this. So when I design my board, I know, okay, this is my voltage regulator for 3v3, and this is my battery charging IC. Because now on my boards, these are two exactly the same. So the footprints are commercial. If that makes sense. So this MSOP8 is a generic footprint. But then they do magic inside, and you don't have to have all the pads. That's why sometimes you have a connector IC that is not connected or something. So you'll see an NC next to it. So they just take a generic footprint, and then they make their chip for that. Why is everything locked? What do you mean started? I did analog electronics at university, and to be honest, touched a bit afterwards, but I prefer the digital, to be honest with you. Analog is hard. It's difficult analog. It's a skill on its own. So my analog electronics is not professionally up to standard. Analog, you mean op amps and all that fun stuff. C2. To move this, I just push M for move, and then move it just to make it neater. I just want to make sure that I've got my, so C2 and C3, so not this one. I need to unlock this stuff, man. Very good questions, though. Some of the stuff I don't think about, actually, I just sometimes do. No. So the pink color is silk. The blue is for your fabrication house. So sometimes you can see it's actually fab, I think. Yeah. So when you ask PCBWay or someone to populate your board, you can add this extra layer so they can double check what components are supposed to be placed there. So at a production house, you've got your PCBs will go in and the stencil's on top, and then they'll put solder paste on it, and then it goes to a pick and place machine, and they pick it, and then put components on, and then it goes through to the oven to the end. So at the end, when they normally do one board to check if everything's fine, and then in front they'll have a computer with your files, and then they'll see the blue. So you won't see the blue on your board, but the blue will be on their system to say, okay, C2 is supposed to be 10 microfarads. Quick check, it's fine. So it's more for the fabrication house when they do your board. So only the pink is your silk, your bottom silk, you can see here. Good question, man. Good question. I hope it gives you a good explanation. If I don't explain stuff well, guys, just tell me. I'll speak slower. Sometimes I mumble. Sometimes I speak fast. So I don't mind repeating myself because sometimes I don't even understand myself. See one. I have to make settings that my KiCad and my Altium has the same buttons because I keep pushing Altium buttons or things like that. Strange. Mostly able to follow. Yeah, it's a sequence of events. So they always check your first board at the end of the reflow oven. So these are for the fabrication houses. That's why it's BFab. So you can see, they can see the blue, C2. So this won't be on your silk. Hey, Nico, how are you doing? Do you manage to install KiCad? Wonder if FreeCAD. Yeah, okay, that's different though. I can help you with KiCad and Altium. Fritzing is that program where you can like make like real breadboards in real life, right? Or what's fritzing? Instead of FreeCAD, you can also use Fusion 360. That's also free, and I prefer that over FreeCAD. So it's Autodesk Fusion 360. That's also a very nice software to have. So Nicole, just say when you're ready, you want to pop up, and then I can help you with starting your first PCB board. Yeah, you just highlight it, and then push R for rotate. So highlight, and then just push R, then you can rotate it. And you can push X to flip it. So if I push X, it flips. See? So it rotate, and then X is for flipping. Basic board. Did you do PCB design in Fusion 360 or the housing for it? I've heard about that. I haven't tried it yet. I don't know if Fusion 360 can do PCB design, to be honest with you. Yeah. That's cool. So we use Fusion 360 to also create the design or the housing for electronics, and then we 3D print it. That's cool. I don't know that. And have you guys used Eagle and KiCad and Altium? Like, I can't say too much. I've never used Eagle before, so I don't know the pros and cons. So I just like to put all this stuff nice together. Eagle's a software I started with. Yeah, the company I first worked with used Altium, and they trained me in Altium. So I'm a bit biased when it comes to that. I shouldn't say that on live stream. Nickel, you're a student, right? You can get it for free. You know that. I don't really want to help you with KiCad if it's cracked. With Altium if it's cracked. I want to stay legal. I'll help you offline, but I can't bring you on with Altium open and it's not legal. That's a bit. Yeah, my experience is most companies now use Altium that I speak to. Or Mentor Graphics also, but I don't like that. I think you just put your high school name in. I don't think it has to be a college, eh? I'm not sure actually, because what they do is they revise it or review it, and then they say, okay, you can have it or not. So if you just tell them your high school, they're very nice when it comes to that. Where's your college? Yes, no, I agree with you. If you want to start with KiCad, because the concepts stay the same, guys. PCB design, the big concept is still the same. Schematic, PCB, linking the two, component placing, they're all the same. And then when you get to a company, you at least know the basics. Then it's just about navigation. And Altium has more features, makes it actually easier. So that's very good advice. Just get started, guys. Doesn't matter what you use. Just have fun. R7, R6. So what I'm doing now is I'm just making it, I like to make sure that all my components are like together. So I know this is a circuit. So I try to place them closely together before I take them to the board. All preferences, guys. Build a battery charger. So build a Lipo battery charger. So have a thinking now. Maybe take a 12 volts, make it to 5 volts, and then charge the Lipo battery. So you can use an IC like MCP781. That's a nice battery charging IC for all your Lipo. That's a practical project. So I don't know if you use Lipo batteries a lot, but I use a lot of Lipo batteries because I like to have wireless. So inside here is a Lipo battery. Yeah, anyone with ideas, easy, nice beginner's project someone can start with on KiCad? Yes, so I'm on holiday. I was supposed to go away for Christmas, but then we're in lockdown now, so it gives me something to do. I like chatting with you guys. I like helping you guys. So I'll do it every day. Tomorrow, I'm going to speak to Mr. Hornet, the drone speed professional flyer from India. So we're going to have a little podcast tomorrow. So I won't do this tomorrow, but then every day, probably Christmas, I'll skip maybe. Don't know if we're going to do anything for Christmas. Yeah, but I'm planning to do this every day until the 4th of January when I go back to work. And then I'll do this every weekend. The battery charging circuit. So that is on YouTube. Let me find it for you and I will show you the link. Design your own battery charger. It was actually part of a live stream. Here we go. Found it. I'll send the link, Nicole. That's also a good idea. On top here, KiCad also has examples, I think. I've actually never played with it, but if you go to KiCad and you say open project, where does it install KiCad? Somewhere there was examples, I thought. Demos. So in KiCad's documents, folders and stuff, you can find examples, tutorials. You can play around there. But I sent you the link, Nicole. If you watch that, you'll see how to make a battery charging circuit. We actually made a live stream about it a long time ago. The Gerb is also available on our GitHub. But if you get stuck and stuff and you want to jump on stream, just let me know. Join the queue. There's no queue. Just come online. I'll put you on and I'll help you wherever you need help. So we got this. Measure the battery. R4, R5. Wonder if we're going to fit everything on here. And you can also rotate it not only 90 degrees, but you can change it as well. So here you can see other. I can make it 10%, 10 degrees. I won't advise it. It's normally 45 is nice. But for this case, I might try something different. That's fine. Let's just leave it nice. Just want to show you guys, you don't have to have it 90 degrees always. Will it be a problem if text on the sill screen sticks out of the board in the design? The only problem will be is the manufacturer won't put it on. So you mean like if I've got R4 and R4 is like this, so some manufacturer will email you back and say, listen here, this is wrong. Some manufacturer will literally just make the piece that's on the board. So it depends. Technically, it won't be wrong. It will still work. It will just be cut off. So what I normally do is I normally place all my components and I'll start making it pretty and stuff. But this board might actually be quite compact. So there might be ones where I don't even have the silk on it. It's quite cool because green is underneath, red's on top. So even though it looks like so like this, it will just cut off the bottom piece because they can't make it on top of the copper. All these. What if I do this? It might be a bit easier. Can you guys still see? So nice thing is if you click on something, it will pop up on the left-hand side. Guys, just so if you know, if you join our Discord channel, you have to go to rules and push the thumbs up. So I see there's a couple of people joining, but you can't chat if you don't push thumbs up. Just to say that you will be nice, you will not swear at anyone. Be interesting. So this will be a 4-layer board, so it'll be quite different. 4-layer and round. I wonder if I should make it 402s and make it even smaller. So I'm probably going to send this to be made. I'm not going to populate it. I don't know. If you do copper pole, will that be considered? No. So the layers that I currently have is only 2, so the top and bottom. When you do a copper pour, you are just saying that the whole one layer is full of copper of a certain ground voltage, but it's not seen as another layer. So layers is the physical layer of the PCB. So this will be a 4-layer. So I'll have my top, where I normally put my copper pour, then 2 layers inside, and then the bottom. So I can do that, at board settings, board setup. I can do it now. And then I just choose 4. And then I'm going to have 4 signals. In copper into, and then you'll see it will pop up here. So now I've got a 4-layer board. Cool, eh? Did you see that? Don't even. Yeah. Guys, if something's too small on the screen, just stop me. Because I look here and then I don't really see what it looks like on stream. How to put image of circuit from PDF in KiCad. So what I do is, I take a screenshot. So I make use of a snippet tool. I will just take a image. I will save it somewhere, save as. Just put in desktop for now. And then over here, I should be able to go file, import, nope. Place image, place image. And then I can go to my desktop. And then I can just place my image there. That help? So I make use of the snipping tool of Windows. So just snip what you want to paste. save it, and then you can go place image. So red is the copper for the top layer components, and the green is the copper bottom layer components. Yes, exactly. So you can see bottom copper and front copper. It's top copper. So yeah, that's exactly that. So green's at the bottom, and these you can actually change. You can make it different colors if you want. I'll just keep it default. I'll just double click on it to get there. What is it, red? Oh boy. Yeah, okay. Cool, man. Just keep the questions coming, Nicole. I'm sure you'll have a couple, but it's a good thing you're starting. Right. There has to come a track out there, so I don't want it too close. So I've got a voltage divider here because my battery is 3.7 volts, can be 4.2, but my ESP32 cannot handle a 3 volt, 3.74 volt supply to the pins. Max is 3.3 volts. So you make a voltage divider just to drop down the voltage. Almost ready to root, or try to root, try to get it in. It's gonna be fun. It's gonna be fun. Yeah, I don't think we actually. I'm probably gonna rotate these at funnier angles. Makes it look cool. $30. 25. So we can make the components go all around in circle. I think it look quite cool. And the ESP is a 10 a year, so we can't place any tracks or anything underneath here. Okay. So Nico, what are you making? Are you going to make the battery charger? I'm actually going to delete this switch and add a capacitor here. That reset button is actually just when you want to power cycle your chip. It's in case it got stuck somewhere. But I'll just remove the power. Nice, man. What's going on here? Tools, update, reassociate, delete extra, update footprints. I think we got everything. It's a very nice chip. I like that chip. I like that chip. I think we can almost start. So what I'll do is, I need a battery. Where's my battery? And I need a button. So I'm going to put the copper port that we spoke about earlier. Just make it feedback or ground. Let's make it 3v3. You can see now there's copper on top, so you can see the difference. That green is a solder mask that's over my copper. And you can see it's connected there. I'll do the same for ground. You can keep in control to keep this line straight all the time. Also, my ground is connected. Quite nice. Nice. Yeah, let's start routing. Start with our differential pairs, root differential pair. So to make vars, just push V for via and it should automatically do it. So I normally just connect everything. X is for tracks, and then I will make it pretty afterwards. We might not need 4-layer board, but let's see. So here you can see these are actually next to each other. So I can go like this and connect them directly to each other. I just like always to bring it out and then back in, because when you view the PCB, you can see the track. When it's at the bottom, you can't really see it. So you don't know, maybe the manufacturer made a mistake. So I always like to bring the track out and then back in. I don't like doing this, but there's nothing wrong with it. Let's still do it. Yes, black and white. I like a black solder mask. It looks, for me, it looks way better than green. And yourself, what's your favorite? So I make all my PCBs black and white. Black solder mask, white silk screen. Like this. Welcome back. What are you guys up to this Saturday? I assume it's Saturday all over the world. Saturday is normally my sport day, but there's like no sport on. I see India had a meltdown this morning, but I was sleeping. Blue PCB. I've actually never made a blue PCB. What do you like about it? Took apart the inkjet printer. Took apart an inkjet printer. Yeah, it's quite amazing if you look at your phone, what's inside here, and it's just the engineering behind it. I don't think people understand. Like, these guys are the real heroes. The people making your motherboards, your phone ICs, it's high-speed signaling, all this stuff. There's some great engineers out there, and they spend a lot of time, because this is a simple board. It will take me a couple of hours to do. Now imagine a phone. I should try that. I think you pay extra if it's not part of the default. So I normally just test it and I save money and just get the default. If I push a button and you see something pop up and you don't know what happened, just let me know. I'm using shortcuts a lot, but I'm basically just doing what's on top here. So to get properties, I push E and properties pop up. So please, guys, please ask. Still waiting for someone to join me on stream. Chris said he wanted to, but I think he's having some technical difficulties. But I'm enjoying the questions, guys. Turn up later. Don't want angles. VBus. VBus is just the name of my USB. So the generic term when you have a USB connector is VBus is the power supply. So you just call this VBus. It's the power the USB supplies. But this can actually be named anything. It's just a net name. So it just shows that this is connected to this. But in the common world of PCB design and signals, VBus is the power supply of your USB that your USB puts into the system. Now we just play connect the dots. I might be able to get away with that board here. We can even go smaller. Made this thing too big. So this board currently is about 3 centimeters. Keep pushing the wrong buttons. Another cool thing is because I've got my copper at the top and I've got my copper at the bottom. So I've got my power at the top, ground at the bottom. I can just go like place a track, add a wire, and now it'll be connected because the wire is like a portal through the board, and it will connect to the thing that's required. I'll show you guys. You can see, not that one, it's on top there, right? See, this wire is connected to the top port, and this one's not. You can see it broke it up. This is my ground, which is, or something else from my GPO. If we do a ground one via, and we push B for repo, then you can see here, there, my ground one. So it's not connected to the top, it's connected to the bottom, which is quite cool. What are some of the common errors that prevent manufacturability? Track, so things to watch out for is track clearances, track widths. So your manufacturer only has the capability of making tracks a certain width, not smaller. Also the gap between pads, that's important. But manufacturers can, most of the time, do way more than what we give them file to do, because they think about, they do phones and stuff. So our little board, they most of the time can do it. So putting your components too close to each other. So if you can see this white outline as your mechanical outline. So if I put a resistor like this, things like that. So the pads are fine, they're far enough from each other, but the physical components are too close to each other, so it will not be able to be populated. I'm thinking what else? Also, don't have your components too close to the edge. Also, your tracks can't be too close to the edge. Like you can see, there's a clearance automatically. So what happens is they got a 2mm drill bit or something, and they make these boards for you. So there's always a tolerance when they cut it. So there's a clearance tolerance from the edge of the board. So don't put your tracks or components too close to the board. It'll automatically do it. So when I go ground, it knows I'm busy with the ground. So if I push V, my via will become ground. That's the only reason. So if I just push a via here, if I can do that, it'll be ground because my layer is ground. If I make a track here, I place a via, it will become that. So it becomes whatever track it is associated with, or whatever track you put it on. In your video, how you move the MCPU symbol with help of invisible string. What do you mean? Push M. So if you, I think that's what you mean. So I've got a U, let's say I've got a C, and I want to move it. I push M to move it. So I click on it, push M, and I move. Is that what you want to know? What do you mean invisible string? The rat nest? Move it a bit. When you press M to move the symbol and a string moves it. Okay, yeah. So M worked. I'll try to do my grounds and voltages later. Great stuff. Who knows? Maybe you can order the PCB. That'll be awesome. Your first ever PCB. Nico, will this be your first ever PCB? Exciting. We'll meeting this up as we go. So let's see what we're missing. The game now is just get rid of some rest nests. So now I'm just pushing vias because I know I've got a, this is my ground layer. You see what happens now is I'll throw the copper, but this track's actually cut the copper, which is not ideal. So you can see there's a little island there. But we can sort it out. We can make a quite excited. When you're done, I want to see it. Then you'll be able to charge those batteries. You can go underneath here. It's just ugly, man. Just going to take this. That should be fine. Nice. Yes, you will be able to. So that's the idea. So, like, if Nicole wants to come on and share your screen, and I can help, that's the plan. So you can share your screen once you're on. That is true. Yeah, if it's, I can try. Maybe there's no mistakes. Hey, Maverick. Maybe you do the PCBs better than me, and then you can tell me what the mistakes are. But yeah, please feel free to join. This program is quite cool, so you can share screens and stuff like that. At the bottom, you'll just see the button share screen, and you can share screen. Do you have the link, or must I send you a link to join? Oh, shows. I'll send you the link just in case. Invite, copy. Yeah, it's so cool. It sends it to all the platforms. I like this program. That's it. We connected everything. Can you believe it? See you there. Let me just stop the music. Hey,
Hello.
how are you doing?
Yeah, you able to hear me?
I'm good, thanks.
Yeah, you're able to see my screen?
Not yet. At the bottom, just go share your screen. You can try now.
Yeah, I'll try to share my screen. Yeah, so I designed the board in Fusion 360. I'm not sure if I can keep Chrome on and open the app at the same time.
Hey, Nazar.
Wait a second. Yeah, I'll just open the app and then I'll try to comment. I'll share my screen.
Okay, great. Nazar, we can help you with Altium as well. There's no problem.
Are you able to see my screen now?
Yes, I can add it like this. There we go.
Yep.
Nazar, if you have any questions, just let me know about Altium, and then we can ask it. Yesterday I streamed in Altium. So one day I streamed Altium, one day I streamed KiCad.
It's taking a long time to open.
That's fine. No worry. Yeah, it does the same on mine as well. So you can do PCB design in Fusion 360 as well now.
Yeah, I used to use Eagle, but then I joined the startup and they told me that like everyone is designing in Fusion 360 and it'll be easier to integrate with that.
Oh, okay.
So
Oh, so you're working for a startup. That's exciting.
I left the company though. I'm like
I'm
my
just gonna.
semester end came and then too much pressure, so I said I'm done.
You're still studying now.
Yeah, I'm in my third year of
Oh,
BTech.
nice. For electronics or
Yeah,
electric?
electronics.
Oh, nice. Yeah, I just stopped sharing your screen because you're busy typing in username and passwords. So
Yep.
when you log in, I'll add it.
I thought of it, but then I thought I'm not typing my password right now. So
Okay, yeah, I just removed it just in case.
yeah, you're not able to see it right now, right?
No, you stop sharing.
Yeah. Bunch of stuff, two-step verification, all this. I still there. Suddenly it's just stopped.
I'm still here, yes. Oh, I can see it. Must I share it?
Yeah, Autodesk is not opening.
Oh,
Sometimes they really test your patience. So
yeah, there's no rush. Don't worry.
I'll close Altium. I was trying design Altium, but then I got stuck.
So NASA is working on a project Bluetooth radio, ESP32, PCM. It's getting there.
Yeah.
I can see Fusion 360.
Usually I was part of the team. I guess. Yeah, it's here. Able to see it, right?
Yes,
So
yes.
that I developed. So it has two parts. One is the emitter. That is, if you know how a pulse sensor works, that is, it emits red light and IR light at the same time,
Yes,
and then
yes.
it has a photodiode to receive it, and then measures the ratio or something, and then that's how they measure the oxygen level in your blood, right?
Okay.
So I had to develop two boards for it. One is the emitter. That's just yeah, this is the PCB. This is all it is, the emitter. You can see it and point out any mistakes, but I guess this probably won't have much. And everything is done by auto router. Like I have no experience in manual routing and all.
Yeah. Okay, let's have a look. Nazir, what you can do is in our Discord channel, you can also share your schematic because there are a bunch of engineers that can also help you. So there's 120 people on the Discord. So if you really want proper help with reviewing, it would be quite cool to send it there. There's guys with way more experience than me, 30, 40 years experience of PCB design. So if you're on Discord, maybe send it there. Or we can do it here after this, but let's first focus on, how do I say your name?
It's Ajitesh. It's actually JS my initial, like yours is JP, right?
Sorry, so what's your initials?
JS. It's
JS.
Ajitesh JS, right?
JS.
I just put it together.
I'll call you JS.
Taking a hell lot of time.
That's fine. Let's mute this thing.
Yeah, it's here, I guess.
Okay, seems interesting.
So there are three pins here. Two of them are ground and VCC, and the third one is So this one is VCC for this LED. One of them is LED, red LED, and the other one is an IR emitter. So this is voltage for positive voltage for the IR, and this is for the LED. And I have kept a common ground for both of them. So they'll alternately be turned on and off by a microcontroller at a very high rate. So it's a very high rate of turning them on and off.
Yeah, like PWM.
So what are the possible design flaws in this?
Let's see if I can make it bigger. There you go. So this is the PCB or schematic?
No, it's just one of them. Like I had to make three. So one for the emitter, that's not much. The receiver, there are some circuits and all for filtration, amplification, and then basically signal conditioning. and then it outputs this thing out of a pin into a microcontroller.
Yeah, but this is the only board you're busy with, right? There's nothing more to this.
Yeah, there's nothing more to this one. Yes, I can open the other ones, but I would like to go with the simplest one first.
Yeah, this is, so the LED, so it's two LEDs. Sorry, just say again. Two LEDs.
There's one red and
Yeah.
one IR LED.
Okay. Yeah, this is, there should be no issues with this. This is really, there's no tracks that is
Right.
less than
Do you remember I said that comment, right, about the silk screen and all? See, this is what I meant. This one's just sticking out of the board, but I didn't know whether it was valid or not.
No, so they won't put it on. So even like your JP1 LED, those are also overlapping.
Yeah.
And then your D1 on top is underneath an LED, so you also won't see that.
Okay, so here the case will either be they send me back an email saying remove that, or they just go ahead and ignore that. Is that the case?
They will probably just ignore it, yeah, because they've got so many PCBs. So they'll try to make sure the technical problems are fixed before they care about cosmetic problems.
Right.
But
Okay,
you can move it, right, or not?
Can you repeat that?
You can move the D1 so you can see it.
I actually have a hard time like interacting with those.
Really?
Yeah. See, yeah, you heard that sound, right? This is what happens to me most of the time when I try to move around components. See, it's just everything you don't want to move will move.
It's a schematic. So this is the PCB. How does the schematic look in Fusion 360?
Yeah. Switch to schematic. There's a schematic PCB and a 3D PCB. It was the 3D one as well.
Yeah, so it's the same as KiCad and Altium. They all have three of them.
Yeah, this is all.
That's the schematic.
Yeah, the 3D one. Wait a second. Yeah, this is the 3D. This is how I want it to look. So your finger will go here, like imagine your finger going in like this, and then it would emit the lights here, and the receiver will be in the bottom with the photodiode over here, and then it will go through signal conditioning and all, and then go to a microcontroller.
Yeah, it's like a beambot, where we used to make a beambot which reflects lights and come back, right? Or not? And then if you break it, the wheel will move.
Okay. Yeah, I kind of get that idea. Yeah, so I'll go ahead to the receiver, and this is a bit more complex and wait. Yeah, you want to see the schematic or the PCB?
First start with the schematic.
Yeah. Wait a second. Yeah, so the main one was I guess this is one of those MOSFETs or something, and then so this is a this is the photodiode, right? As I said, this is the one that will be receiving this thing, and then this is a resistor. God knows why I put that. Like I kind of did this like 6 months ago or something, and then I kind of forgot about that now. Yeah. So this entire thing is basically a signal conditioning circuit. You can take it that way, and then here it gives the output as a pin, right? I kept a pin over there like a male connector, so that I could connect it. Like it was still in the prototyping development kind of phase, so I decided it would be easier if I could have like disconnectable pins instead of like making anything solid. So I have this pin over here which gives the output signal, and this goes to a microcontroller. I've developed a board for that as well, a simple one, and I'll switch to the PCB.
There's a comment. So when you do a schematic design, just try to make your designators easy to see, because like you said, you came back 6 months and now you have to think what actually happened.
Yeah,
so it's always nice to just have comments and stuff.
Common. Yeah. Got that. Go back. So what can I do different over here? Wait, I'll go back to the schematic. Yeah. So power is also provided by pins. I actually didn't
Okay.
know how to set like that copper board thing, like, or set a layer separately for VCC and ground. So what I did was I just routed them like normally. So
Yeah.
that's what these symbols I've connected to these two connector pins. These two pins I would have given the power in like
Yes.
plus and minus. And then yep, I guess you get the point. Now I shall go to the PCB. Yeah. Errors here. It's all auto routed. I didn't route anything manually.
Yeah. So, word of my advice I give everyone is don't auto route. I don't prefer it. You don't really have control of it. So there's a bunch of stuff here that manufacturing wise is not ideal.
Yeah.
So if you, what's the distance between your tracks there, close to R3?
Here.
Yeah, if you zoom in there. Okay, it seems fine. So like I mentioned, the manufacturer has a certain specification of clearances. We just have to check like that. But like you see at some traces that join each other, let's say at the like connection like C3 goes to C2, that there where you pointed.
C3 to C2, yeah.
There's like
This plus.
that's not ideal.
Okay.
It's fine. It's just, and you can see NS6. So
Where do I go?
zoom into C2.
C2. Yes. Yeah.
So just a rule of thumb is when you make a track, you don't want to enter the pad at an angle less than 90 degrees. So you see that small angle there.
Is it this one that I'm
Yes.
circling?
So that's that angle that you see, NS6, is less than 90 degrees.
Okay.
And that's not ideal because they use acid to remove the tracks. And when they use the acid at small angles, the acid can get trapped into the angles. That's called the acid trap. So that's not ideal.
Yeah, I actually been reading some blogs. I came across that. I realized that now. So how do I? Okay, yeah, this one. I actually auto routed it.
Yeah, that's what I say. Don't auto route. Computer will just go from A to B. It will not think about rules.
So that's another point for manual routing.
I never auto route ever. You can.
And how do I fix this T? Like, how do I modify it to make it
I'm not
better?
too sure in Fusion 360 if you click on it and move it, what happens? I'll have to play with Fusion 360. I'm not too sure. Hey, you moved it.
Yeah, I guess I did. I didn't know what I was doing, but somehow it did.
Pick up. Right click again.
Right click, yeah.
What's that? That's rip up. ResNets move. There's a move.
Move.
Right at the bottom. Yeah, there we go.
It's gone. Wait.
Okay. There we go.
Okay.
Like that. Go down. So that is up.
Yeah.
Like that. Down. Like that. That's how you want the track to go in.
Okay, so this 90 is fine, huh? This 90, it's coming out at 90, right?
There's a 90.
There's a 90 over here. That's all fine.
Hey, Abhishek. Yes, but because later on we will speak about it, but you can do a teardrop. So, do you know what a teardrop is?
I guess you talked about it in one of your videos, but other than that, no.
Yeah, so it's just it makes the copper go out and then in a bit just to give it more copper at entrance.
Okay. So what does it do? Like it kind of smooths out these edges?
Yes, so it will take a line from the beginning of that track, that little small track. So move to the left, but to the left at the beginning of the track. Yeah, there. Just a small track, yeah. So it will take it from there and just make like a cone all the way up.
Like this?
No, straight. straight up, out. Yeah, like that.
Okay.
So we'll create like a cone shape so you don't get a 90 degrees.
Okay. Fine. Yeah. So, what about the component placement? How can I make it better? What's wrong here? Like, because I didn't think about any of those manufacturability, none of those I thought about. I just placed these components over here, set it order out, and then I was actually quite embarrassed about this, but
No,
yeah,
no,
I'm still
no,
learning.
no, but
I am an
don't be
amateur,
embarrassed.
still
You have to
learning.
learn. Don't be embarrassed.
Yeah.
I would, so if you go to your schematic,
I'll go to my schematic just a second. Wait. Yeah.
so you want your components that are close in schematic to be close on the board. So
Okay. Fine.
I always look at my schematics. I've got my R7, I've got my D3. So those have to be close. You know what I'm trying to say?
Yeah. Just a second. I'll unmute myself in a second.
Okay. How are you doing, Abhishek? Guys, sorry if I say wrong names.
Yeah, I have to go now. I hope I'll continue this session like tomorrow or any of the other days where I'm free.
Yeah, sure. No worries. Thanks for joining. So I'll probably do this again on Monday. Tomorrow I'm going to have a chat to another guy on our podcast. But yes.
Okay, bye.
Bye. He was in a rush. Oh, that's funny. So that's good, guys. That's what I enjoy. So please ask questions. Where is Krish? I thought he wanted some help. Okay, let's carry on. Let's see if we can finish this board. I just want to add a battery connector. Come on. Welcome back. Are you done with your PCB? You want to show it? No worries, no rush. Just say when you're ready and we will get you on stream. Quite excited to see it. Just have to neaten this up. But you guys can see now if I go design rules, I should get no errors. What errors will I get? Unconnected, lies. Yes. That is a library on what's the place called? It's a library you have to download and install. In the comments, do I mention it? Because I think someone also asked me it. Just look in the comments of that video. Do I give a link to where to download the library? I can show you. It's what's that company called? Like Fruit, but the other one. I think it starts with the S. You can use any power symbol. So VBAT is just the name, but just make sure the names are the same. But I can show you that when you're online. It doesn't matter. We can install the library and install the library. Download the library and install the library. No. So it's important. Maybe I've got a schematic here. So VBAT is literally the battery's voltage, and VBus is the voltage of the USB. So it's important that these cannot be the same. Otherwise, this will go directly to the battery. So you can make it a different name, but don't make it the same name. These are two separate things. VBus is the voltage of the USB, and VBAT is the voltage of the battery. I can use the VBAT. Let me find it for you. I think in the video at the bottom. Just gonna have a quick look. SparkFun. It's a SparkFun library. So I'm watching my own video now. So you want to know how to use SparkFun? So here you can see there's a KiCad library for SparkFun, and the VBAT's in there. So you can download it. So if you go to this website, I'll send it to you in the chat. And then I can quickly show you how to install it. Hey, Electro. What do you mean how to use it? So you just go to the top here, say Tools, Inspect Design Rule Checker, and it'll pop up. And then you can see, you can change some stuff, minimum track width, bias size, what to look for. I use it mostly just to check what I am not connected yet, because that's important. So there you can see I've not connected something. But then we'll also look at the rules you've set up. So you can do design rules as well. I made a video about this, but there's rules, classes. So you can set up different, for different nets, have different rules. So that's also quite cool. I hope that answers your question. Mission accomplished. That's quite a nice way to put it with your profile picture being a rocket. Let me open it. So you download it. So if you go, now I have to remember. So if I go to my schematic, if you go here, preferences, manage symbol libraries. Oh, you don't see, oh, you do see it. So you see that, manage symbol libraries, you click on that, and then you can add. So you can see, I actually should have it somewhere. So you can just click this button and then import it. So add one. So you can see SparkFun, I've got it already. So use these two buttons to add it and then see what happens. See library. But let me know if it works. Otherwise, we can try it, yeah. So this is the window where you want to install it. Symbol libraries. So it is great. So now it should work, right? So if you go preference, manage library, global libraries. Let me just see, KiCad library. Oh, that's plugins, not libraries. And then you should be able to add it. Did it work? So sometimes you can move stuff around. So it's complaining that my ground here is not connected to my ground here, because if you look at the pause, it's cut off by this track here. So if I move this track and I connect to this VPAT, then this path will be open to be connected. Hey Patrick, how's it going? Now cut it off there. It will be it will be this power symbol battery. So you see at the bottom here, when you double click on a component, you can actually see where it comes from. So the library reference will be this. So if you import the power symbols library, it should work. NTC or NFC? I haven't really worked with NTCs a lot. You mean for temperature safety? Or? Like PTC, NTC? I haven't used it once or twice with power protection overheating. What's your question about NTC? He wants to use it for a Leon battery. I don't know, let me go BQ242. Two, 4, 2, 3. What made you choose this IC? Yeah, sometimes we have to do the grown-up stuff, eh? I see me asking for this reason. NTC thermostat input. So it's just temperature, so it gets to hot. Nice. So the library helped. Also, a lot of these batteries that you buy now actually have like small circuits inside them, so they protect themselves because they don't trust us to protect it. So if you short circuit a battery or something, it shuts down straight away. What's your question, Patrick, or what you thinking about? Strange. Yeah, everything's connected now. I had to make a copy of a symbol in KiCad. Control C, Control V. What do you mean? To make your own footprint or just to copy it in the sheet? Footprint's another another story. Now I need to add some sort of button. Just want to see. I want to get a step file of a squash racket. I don't know if you guys know about this website, but I use this quite a lot. GrabCAD, so I can get nice step files of just random stuff actually. So this idea is I want to put the PCB at the bottom. So I actually want to see if it's possible. Like a resistor symbol is there, but you want to connect another resistor symbol. Yeah, you can just highlight Control C, Control V, can't you? Copy paste. Just want to save this. just extracting the step file and stuff like that. So I'm going to put in Fusion 360 and I'm going to import this PCB, and then we have a look. I'm pushing the wrong buttons, man. There we go. Let's hope the PC doesn't crash with everything I'm trying to do. The Control C and Control V work, Nicole? Let me know. So, yeah, let me just show you, right? I'm still saying it. So I assume you want to go like highlight this, Control paste, or not? So maybe I should add a vibration sensor. Just highlight it and push E. Then you can see the properties, and then you can see the value, and you just change it. Or you can double click on it. Just waiting for Autodesk to start. There we go. So the idea is to get this, what? I've not used this in a long time. Freeze and freeze. Ah. So I want the PCB there. So we can file, export, step file, export. There it is. So this is not going to be there. I'm going to solder a battery to it, a small battery. The idea is just, can I, how do I import something here? Maybe I'm going to save it first. Oh, not good. I don't know what's happening actually. I can't upload. I think my license ran out. You get a year for free. Oh yeah. There we go. Good sign. Oh, there we go. Might have to make it smaller, but it's fine. I need to rotate it. So that is the idea, to get it on there. And work. So I'm going to add like a maybe vibration sensor or button. So every time I want to point, I just push that button with my hand like this, or maybe better because when you hit the ball, there might be vibrations as well. But I think this can work. Just a button on top. Button, button, button. Just looking for a nice symbol. You managed to change the resistor values, Nicole? I wonder if a reed switch, that might be fun. Then you must just be sure that you wear something magnetic. Come on. Let's find a re-switch. Oh, it's a bit big. Welcome back. Don't think this will work too well. I normally take what's in KiCad, or if someone's made a library on GitHub, I take that. I try not to make my own footprints. It takes a lot of time, and some people have already done it, and some people have made good footprints. But if I really can't, and there's no footprints, then I'll make my own. But there's lots on GitHub. This is going to be interesting. I don't know what's going to happen if you take a magnet so close to the ESP32. Interesting. So reed switch, normally you take a magnet and it opens and closes depending. But don't know. I'm quite interested to see what happens to the ESP32 if I take a magnet close by. I'm going to try. I want to change the connector for the battery. I want to not have through hole. Just want something to solder on, like solder pads. Is that a thing? Two pads. Ah, come on. See, now I'm just being lazy. I don't want to make it own one. I'm looking for something to solder on. Oh, I can actually use this. I need to charge the battery, so the battery should be underneath there. So I'll probably make like a housing that they can just... Huh. Do you think someone drew this for us? Eh? Literally just need those pairs like this, man. Good. That's good. Now we just go through and make sure that we satisfy all our rules. Oh, perfect. 0, 0. Closing stuff I'm not supposed to close. It's got a nice shadow. Push okay. Quite excited to see how this fits. No, come on, come on. So the idea is to have a reed switch there. So when I play squash, I tap it, and then it's going to count my scores. So both rackets will have ESP32, so we can use the ESP32 NAR protocol, so communicate with each other, and then display the scores somehow. Maybe make an extra watch you can wear under the ESP32 that will keep track of the scores. But I think to start with, I just want to make 2 of these and let them communicate with each other. Got so much space here. Probably be like this something because there'll be a small battery here. Nickel, how's it going? Nice. You want to show it? I think I'll stream for another 20, 30 minutes. So maybe I can help you. Do you want to show it? I don't need to make it 4 layers anymore, so I'm just going to make it 2 layers. Then get online. You know how to get online, right? Just I'll send the link again. Looks good. Just have to clean this up. Someone has joined. Hey,
Hey, what's
how you
up?
doing? Good, man, good.
Very hard work to create a
Hard work.
simple PCB. I'm creating this when
Yeah, you can share your screen if you can.
1 second. Uh, where is
At the bottom, there should be something like share screen.
yes, share screen.
Let's see. Maybe I should remove mine. Oh, there you go. There you sharing.
My screen is visible now.
Yes.
So this is
Nice.
the circuit.
You must just annotate the schematic. So you see all those question marks. So you see D question mark, R question mark.
I want to ask you, what's the next process?
So you haven't taken it to the PCB yet.
No.
Okay, so you can see all the capacitors and resistors. You see like R question mark, C question mark, U
Yes,
question
yes,
mark.
yes, yes.
Those are called
That's
designators. Yes, they're called designators, and they need numbers. So to get numbers, you have to go to Tools.
okay. Tools.
Tools, annotate schematic.
Where file.
No, Tools.
Edit.
On the right-hand side, next to
Okay,
Preferences.
tools.
And then go annotate schematic.
Schematic.
Annotate down. No.
1 second.
Annotate. No, not that one. Annotate. More down, like the 7th down. Up, down.
Okay, annotate.
Yes. Click on that.
Annotate.
Yes, and then you can say annotate. Yeah.
Yeah.
Now everything will have numbers.
Yes.
So that's important because on your PCB, those numbers will be linked to this number. So if you close this now,
Okay.
so we have to make sure that all your schematics has footprints. So for example,
Okay.
if you double click on the capacitor, any capacitor,
Okay. Click on capacitor.
go to the settings. No, sorry.
1 second.
Yeah.
When I
You
click
must highlight it.
capacitor.
Click on it. Not on the text, but on the component itself. Not there, on the component. No, you must select. No. Select. Where you
Select
were.
capacitor.
Yeah, but you're doing something else now. You're going to place a component. Push escape. So push
Skip.
escape. Yeah. Now click
Yeah.
on the capacitor, not on the text, but on the physical capacitor itself.
Okay.
A symbol.
Symbol.
Yeah, you can see the settings that pop up.
Yeah.
So push E.
Push E.
Oh, yeah, there we go. So you can see your
So
footprint.
this is footprint.
Yeah, so your footprint's empty. So if you go on there now, click on the footprint, and then click the
Okay.
library symbol on the right-hand side.
Here, right hand side with symbol.
There's like a book. There's a symbol that's got like books and there's left. Right next to the text where you're typing. Go a bit more
Yes.
left.
Okay.
No. Did you click on it? Okay, that's new. And then there somewhere you have to go to capacitors. Capacitors,
Okay.
SMDs.
Which capacitors?
On the left-hand side, you can see capacitor, capacitor 10, so capacitor SMD.
SMD. Okay.
And now you have to look for 0603.
6.
So just scroll down there. Somewhere you'll be able to find a normal, so you get different footprints. So normally we use 0603. It's nice to solder. So if you just look for capacitors in this list for 0603 footprint.
603.
0603, yes.
Yes, that's
It's not moving on my screen, but yeah. So it's just a capacitor that shows 0603. Yes. Okay, push OK, or just double click or push OK.
double click and push. Okay. Okay.
Or yeah, you just need double click, I think.
Okay. So then I press OK.
Yeah. So now your schematic is linked to that footprint. So what you want to do
Okay.
now, yes. But now you want to do that for all the capacitors. So go back where you were.
Okay. So now I'm doing with this capacitor too.
Yeah, but go back to capacitor 1 because you can copy that footprint and paste it in capacitor 2. Then you don't have to go through
Okay.
all the stuff again. So go back to capacitor 1.
Okay. I'm going back. And copy this. Is
And then paste it there.
you done?
Okay, great. So is there any other capacitors on this board?
There's only two capacitors.
Okay, that's fine. Now we have to do the same with resistors and LEDs and things like that. So before we take it to the PCB, we have to make sure that all our footprints have, all our schematics have footprints.
Then resistor. So which one I choose for resistor?
Also
I should choose
0603.
for resistor.
So it's also 603. So if you go down to resistor SMD, you can also choose 0603.
Resistor SMD.
Yes. So the
Okay.
difference is just
Alright.
through holes and surface mount components.
Which one?
SMD. SMD is nice.
SMD and which number? 603.
0603, yes.
603. Okay. 603.
So
That's
that's the size of the resistor. So 4 to smaller, things like that. So you want to copy this because you're going to paste it on the other resistor again.
Okay. Yeah, copy this. So
Hey, Chris.
okay. So singular.
Yes.
Okay.
So, and now we have to check all. So the LED also probably doesn't have one, or does it? If you double click on the LED.
LED.
Yeah. So we must check
LED.
all the
Okay.
schematics. Do we have footprints for everything?
That's hard work.
Yeah, PCB design takes long.
So LED SMD.
I'm not seeing anything, but yes, LED SMD if you have. Yeah, there. It's a bit
So
slowish. Yes.
should I choose the 603?
0603. Yeah, we keep the same sizes.
Okay. Okay. Okay, then now
And now your USB, does that have a footprint?
USB. No.
So now we have to choose a footprint as well for it.
Okay. Which footprint for USB?
I normally use Molex. So Molex has some nice ones. I usually do micro B. So
Which?
just micro B. So if you go to
Starting from M?
I'll have a look at mine now. If you go to, do you have
Wait a second.
micro B USB Molex? I'm going to send you in chat what I use. I can send you our chat, I think. I sent in the chat what USB I normally use on YouTube. Yeah.
Yeah. So, which footprint for micro USB?
Yes.
Which one can you repeat?
In the chat, can you see the number? 47346.
Okay. I'm seeing chat. This USB micro B Molex. Can I copy it and paste in the footprint?
If you have the library, then yes, you should be able to. You can try. Otherwise, choose any micro USB. So
I can't find it.
sorry.
I can't find it.
Then maybe just use any USB. I wonder if I can take a photo. Can I post a photo? Let me see if I can see your screen. So if you go to the left-hand side and you go to connector, under
Yes, connector Molex. Yeah.
Yeah, your screen's frozen on the right-hand side. But you can choose any USB. It doesn't matter. So any micro B USB you can use.
Micro B Molex 47346.
Yeah, but you don't have to use that one if you don't want that one. So you can use any one that you would like.
Okay. But now I can use this micro B Molex piece.
Yeah, if you have it, you can use it.
Yes, find out. Done. Hello?
Yes, I'm here. Okay,
Yes,
perfect.
done.
So now you've got everything, I think. So if you go to, just save it, always save.
Hello?
Hello, yeah. Did you save the project? Just save the project?
Save the project.
Yes, because we're going to update it now, and just now something happens that you lose everything, so I'll just save.
Okay. Yes, saved. So how can I see it in 3D?
No, you must first put it in PCB. So you haven't done that yet. So if you go tools.
Okay, tools.
And then you can go tools, update PCB from schematic.
update PCB from schematic,
Yes.
but this pop-up cannot update the PC because the schematic editor is open in standalone mode.
Where's your Altium, your KiCad project? So this is the schematic. Where's your project? So push OK here.
Can I make the PCB from this schematic in Altium?
No, but let's just finish here. You can, but you'll have to redraw the schematic. So if you go to KiCad at the bottom, like your main window. So this is the schematic.
That's this KiCad?
Yeah, the KiCad project. Yeah. So, and if you test, okay, I see, double click on the PCB.
This?
On the left-hand side, you can see PCB on top of the schematic.
Okay, yes, this?
Yes, double click on it. Let's open it.
Yes. This?
Maybe say no thanks. Okay, it doesn't matter.
Okay.
And now try to say, back to your schematic. So save everything, save the project, save your PCB, save your schematic, wherever you're working on.
Yes, my all schematics are saved.
Okay, and the PCB is also saved and the project saved. So everything is in one folder.
Yeah.
Okay, push tools update now.
Tools.
No. So on the schematic side.
On the schematic side.
Yes.
Which?
So if you go back to your schematic.
Okay, get back to schematic.
And now if you go tools update.
Tools. Update PCB from schematic.
Yes.
But this cannot update the PCB. What is a standalone mode?
How did you start this project?
What?
How did you start this project? Did you go file new project?
No, I just click on this schematic layer editor.
So you have to create a project. So if you go file new project.
File and new project.
Yes.
Yes, that's my projects.
And double click on test. Let's try. You always have to create a project. So let's make a new project called test2. And
Save.
Yeah.
Okay.
Yeah. But now you're going to have to just go to the test schematic on the left-hand side there. Double click. No. Down.
This.
Yeah.
Double click. Yes.
Right. Go file.
File.
Append schematic sheet content.
1 second. File.
That one. Yeah. And now choose your old test one.
Okay.
Is it that one? Okay. Say
yes.
Use absolute path. Continue. Okay, it's fine. Perfect. And now try to go tools update or save it first. I've never seen it.
Save it. Okay.
And now go tools update.
Save. Tools update.
Yes.
Yeah.
Say reassociate footprints by reference. The top second one.
But now
The
once
top-
again, but this showing one error.
Yeah, I will explain now. It's because we didn't add a footprint for the J2 connector. We're going to fix that now.
Okay. So update PCB. You have to update footprints also.
You don't need that. That's only for you when you already have components on the board. You need to do that. For now, it's not important.
Okay.
But we'll get there. Okay, you can say update PCB. It should add everything except the
Okay.
J2.
Update PCB.
Close. No, close. You have to push close. Exit the window.
Close.
Yeah. And there's your components. So if you highlight everything, you can move it to the center. And now,
Oh,
if you go back to the
that's so small.
small components.
Yes.
If you go back to the back to your schematic,
Okay. Back to schematic.
and if you double click or go to the properties of J2,
Properties of J2.
yes,
Okay. That's
on the connector, not on the text.
yes. Okay. On the connector. Symbol. Okay. And E.
And then you have to go to footprint again.
So which one?
You can go to battery. Is there a battery connector? Go to,
Battery.
no, sorry, rather go up connectors.
Connectors.
Go to connectors at the bottom. Let's just look at it.
Connector.
Yeah, just go down a bit.
In connectors.
No, on the left hand side. So you got connector,
Okay.
mouse connector. Just slowly. I think there should be. JST. Is there connector JST somewhere? Go down.
JST.
One
second.
There.
SJST.
JST, yeah. So look for 2-pin connector there. BM02B. I think the second one should be a 2-pin connector.
BM02B.
Yeah, zoom in there. I can't see.
That's one.
Yeah, I can't see it.
Hello.
I can't see the footprint, but yes, take that one. I can't. Yeah, let's see how.
Okay.
And now you can tools update again.
Okay, tools update. One second. Oh, I connected it. No, 1 second.
Why are you closing it?
Yes, this one. This previous schematic. Symbol E. Footprint. That's one. Connected GST. Okay, done. Tools update. So update PCB.
Yes.
Yes. Close.
Yes. Now
Okay.
there's a connector. Nice. And now you can start making a board. So if you push Alt 3, you'll be able to see it in 3D.
Okay, Alt 3.
Yeah.
Alt 3.
Yes.
Or Alt F3.
Alt 3, not F3.
Alt 3.
There we go.
That's cool. So what is the use of J2 here? There.
So when you buy a battery, a Lipo battery, it normally has a connector you push in. So you'll get a connector, a female connector, so you can plug in your male connector. Or you can just solder the wires on, but it's much neater if you're connected to a connector.
Okay. So how can I arrange this in a best way?
So you go look at
This
your
look great.
So you look at your schematic, see what components are together, and then do the same on the PCB. So you see that all the resistors, capacitors are together in that little box. So they should all be together. So try to
So,
work left to right.
okay. Connect the capacitors with in this.
So everything around your U1, your MCP 73831, they should all be close to each other.
Okay. So that's also takes much time.
Yeah,
Any
it's
time.
going to take some time. But I think it's a nice place for you to play with. So we do also have YouTube videos that can help with this.
Yes.
So
Okay.
you know how to make a board outline?
Yes.
Okay.
This one.
No, no, no. If you go back to your PCB, to change the size of the
Okay.
PCB, do you know that?
Back to PCB.
Yeah, so you know about the edge cut layer on the right-hand side?
No.
Because if you, to make the board outline, you go to the edge cut layer, sorry.
Where?
On the right-hand side, you see all the layers, right on the right-hand side.
Yes.
So there's layers, FCU, BCU, on the right. More right.
One second. More, I guess. This.
Yeah. So you see edge cuts at the bottom.
At the bottom, edge cuts. Yes, edge cuts.
So you click on that, and now you place a line on the left-hand side, on the right, more right, just more right. So where you were, right, other side.
So how to put?
Other side, go to the lines. So where you were with the edge cuts, go
Yes,
back.
edge cuts.
So on the left-hand side, just on the left, there's no, just to the left. That's far too left. Stay right.
Okay.
So there's like a circle.
Where in these options?
Yes. So
Yes.
above the circle,
Add graphic circle.
just one above it. No, down. That one. So you're going to,
Okay.
yeah. So click and
Click.
click, and then keep on control to keep it straight. And then you click again. And now you keep control in, it makes it nice and straight. And then click, so you're busy making the size of your PCB.
Yes.
There we go.
That's perfect.
Now if you go Alt-3, you'll see that is the size of your PCB. So you're going to have to move.
Where?
Yeah, that's the size of your PCB now. You made it.
Okay, that's not visible.
What do you mean?
The edge cuts.
No, because the edge cuts is the dimensions of your board.
Oh.
Yeah. So now you're going to have to move the USB to the side of the board because a USB needs to be on the edge. It can't be in the middle.
Okay, so one second. It's not selecting. What's the next process?
Is to place components. So you would have to move your USB to one side, you're connected to the other side, start routing it. So to route, you push X.
Push X.
Yeah. And then once you click on a pad.
Click on a pad.
Not a pad. Copper pad.
Copper pad.
So the red stuff you see on your component is called a pad.
Yes.
Yeah.
This.
So, yes, that's a pad. So if you push X and click on it, now you're routing. You can see the track there, and it highlights where you have to connect to.
Where to connect it?
It highlights it for you. So you can see there's dark red now and light red. So it's telling you to connect where all the light red is. Click, yeah, that's fine.
Okay.
Yes.
That's correct?
Yeah, because it's light, so it shows you where to go.
Yeah. Okay.
So
So
those
now
if you click on VPass, they will show you exactly where to go. You see it makes everything light.
difficult.
There we go.
That's correct?
Yes. But
Okay.
you're going to have to move your components around there. So you first place your components where you want them. You can see on the USB, there's a small line called PCB edge.
So I want to ask this. This is a very small circuit. This circuit charges the batteries.
Yes.
Okay.
Why? Don't you believe it?
Very small.
Yeah, the U1 is quite a nice IC.
So when I want to charge a battery, then I plug the battery's positive terminal and negative terminal in J2
Yes.
and connect a mobile charger to this circuit.
Exactly. And it's going to charge your battery for you. Exactly that.
Only 3.7 volts.
Yeah, a Lipo battery, yeah.
Yeah, lithium ions battery.
Yes. And then it will automatically
So
stop charging when it's full and things like that.
so whenever I click all on these copper belts, then it shows a path for me to connect.
Yes, exactly.
Okay. Then I can do the rest of tomorrow.
Yeah, but then just shout if hours are going, if you're struggling with something. And then
Yeah.
Monday we can come back and carry on or whatever. Doesn't matter. But I'm glad you made your first one, man. I'm quite excited to see it done. So you can make the board also smaller, eh? So the board doesn't have to be that big. Your edge cuts, it can be smaller. So it doesn't have to be so big. So you can make it much smaller.
Yeah.
Great.
Okay.
Well done.
Thank you.
Have a good day. Let me know in Discord or wherever if there's any issues.
Yes. Thank you so much.
Pleasure. Have a good day. Okay. Bye.
Okay. Very excited.
Great. I'm happy. It makes me happy. Bye.
Okay. Okay. Bye.
That's nice. So that's why we do this, guys. So if there's anyone out there who also wants just help, I can help you like one-on-one with that. There's no dumb questions. We're all at different levels. So please join me. But I'm going to call it a day. It's been a good stream. We built our, I'm not sharing anymore. We built our squash counter PCB. So it's been good. So I'll be back on Monday with some more Q&A, helping you guys, get you guys online, help you with KiCad. Tomorrow I'm going to have a chat with Ranesh about the drone. So we'll have a little podcast there going. So join us for that. He's going to chat to you about India and his speed drone racing, and just he's made his own flight controller. Chat a bit about that. So I'll see you guys next time. Have a fantastic weekend further. Happy Saturday, happy Sunday. Till next time, guys. Thanks for joining. Appreciate it. Bye.